Let's talk about Bernoulli distribution. This distribution is very useful in modeling the phenomena or business processes where there's exactly two possible outcomes, 0 and 1. We will say that the probability of an outcome 1 is p, then the probability of outcome 0 must be 1 minus p, so that the total probability adds up to 1. Where does this distribution come from? Well, one kind of experiment where it arises is a coin toss. So imagine you have a coin and you're tossing a coin. So let's say, why don't I just toss it, right? What did I get? Well, I got a head in this case. But a coin has two sides. It has a tail and a head side. And in my examples, I will be marking head with 1, and I will be marking a tail with 0. So the probability of a head is p, probability of a tail is 1 minus p. This Bernoulli distribution can be used in many different situations. So let's say a disease. You caught a disease and the probability of survival is 1 and probability of not surviving is 0. Or it could be winning a lottery and not winning, or losing a lottery. So you have this probability p and 1 minus p of the other outcome. Okay, very important. There's only two kinds of outcomes. Good. So what about this p? Like, where do we find this p? How? Well, in case of a coin, oftentimes we assume it's a fair coin. And by fair coin, we mean p is probably a half. Exactly 1 over 2 or 0.5, 50%, whatever you call it, right? So we think it's equal probability of getting a tail or a head. So with coins, it's a very good assumption. Although I've seen papers where physicists were actually trying to calculate this p or estimate this p from initial principles, from laws of mechanics of Newton and so on. You could try that, but again, in a lot of cases, if this is just a coin you got at the shop as a change, it's a very reasonable assumption to assume p is equal exactly 1/2. But what if we didn't know anything about this coin, and what if this coin wasn't fair? Maybe someone rigged it and they're using it to maybe play a game with you where they know that the p is not 1/2, right? You think it's 1/2, they don't. Something like that. Or so in this case, I guess what I'm trying to say is the following, that you don't always have a very good and reasonable assumption for p. So with coins you do, but with a case of, let's say, catching a disease and so on, it may be quite difficult to estimate this p from the initial principle. So in this case, we could try to do it statistically.